I'm going to finish with a few comments related to history, okay? Because again, sometimes we live in the wake of big things that have happened in the past, and sometimes we forget where they came from and how important they were. Okay? So one thing to keep in mind is once again the fact that this is something that was proved in the 1600s, even though it was dealing with a problem that had been actually attempted by mathematicians and all kinds of scientists for many, many centuries. Okay, but even the idea of the FTC is not even Newton's, right? We always think of calculus as everything relating to calculus has to do with Newton. Newton is believed to be the father of calculus, but is probably one of the biggest fathers. But calculus had other fathers and mothers as well. Okay, so first of all, the key idea of the fundamental theorem was actually identified by Newton's teacher. His name was Isaac Barrows, another very, very important mathematician, not known as much as Newton is. Undoubtedly, he did not make as many contributions to mathematics and science as Newton did, but he was also he's also a very, very important name that you should know. Okay. The problem with Barrows is that even though he had basically figured out the theorem, he did not recognize how important it was. He didn't know what to make of it or what to do with it. So one of the biggest things that Newton did was he realized the importance of the FTC, and he used it to develop all of calculus. In fact, he developed his own version of calculus, which is quite different from what we use, especially in terms of notation, jargon, symbols, terminology, and so on and so on. Okay, but he had all the right ideas in place. On the other hand, we also know that Leibniz also identified the role of the FTC and developed it, and he's actually responsible for the better notation that we use up to this day, and probably we're always going to use the notation with the integral and the dy dx and so on and so on. But one thing to keep in mind is that these two guys didn't develop, even together, they did not develop calculus to the extent that you see it today. In fact, many technical details were fuzzy to both Newton and Leibniz, and probably if they came back to life today and they saw what you guys study as calculus, they would say, what does that have to do with what I was doing? Because again, there were many, many developments made by people after them in the 2 or 3 centuries since then, and that have changed the way we look at calculus, and we understand it much better. We have made it much easier to set up, to propose, to describe, and so on. If you look at the original papers by Newton on the definition of derivative and the fundamental theorem, you would probably get lost. I would probably get lost, and we would not understand that we're actually reading the fundamental theorem of calculus, because they looked at it from a fairly different point of view. So keep that in mind, play with it. We're going to play with it in class, of course, and then we're going to reap the fruits of the great power of this theorem.